Okay, folks, in the second part, part two, I guess, I'm going to keep working with linearization. So here I've given you the steps for doing linearization, and so I'm going to apply these steps to the next two problems. So I'll let you pause the video and read through them. Okay, so we're asked to use linear approximation to evaluate e to the negative 0.15. So we want to get a decimal approximation on this value, and we don't want to use this function. Remember, the beauty of this tangent line approximation, this linearization, is it enables us to get a solution that's going to be very close to this without actually using the exponential function. Instead, we'll just be simply using multiplication and addition by computing points on the tangent line. So step one in this bullet point said to give a function that mirrors the desired operation. So what function will look like the operation that I'm trying to do here, which is evaluate e to this particular power? The function that I want to pick is f of x equals e to the x. Okay? And then the question is, well, where do I want to center this linearization about? So this is what I've been calling the anchor point. And the anchor point should be a point that's easy to evaluate in the original function. But the other thing is it needs to be close to the point that we want to evaluate. So our goal, then, based on how we've given the function here, is we want to know what is f of negative 0.015. That's our goal. So I want to pick a point that's easy to evaluate in the e to the x function that is also close to this negative 0.015. So pause the video for a moment and think about what that a value should be. So we want to center this at a equals what? So go ahead and pause the video and decide where we should be centering this linearization at. So we want to center this linearization at a equals 0. That is, f of 0 is easy to evaluate in the function. So why? 0 is easy to evaluate in f of x. Okay. And 0 is close to negative 0.015. Okay, folks, this second step here where I say pick a point that's easy to evaluate, that's for doing the problems in this class. In the real world, the way you would think about it is you would actually collect a data point. In this case, you'd figure out what the order pair is with for when x is 0. You'd find that data point. You would calculate the rate of change at that data point by some means, and then you would construct a tangent line to then extrapolate other values looking into the future. But in this class, in order to answer these questions, you're going to pick your point the way I just described. That it's got to be easy to evaluate in the desired function and close to the point that you're trying to evaluate. Okay. So now actually let's build the linearization. Okay, so L0 of x in this case, well, that's still going to be just the tangent line, so that's f prime of 0 times x minus 0 plus f of 0. Of course, I could simplify things like this x minus 0, but I want you to see that this is just that linear approximation that we talked about on the previous page. It is just this, let's see here, it is just this linear approximation right here. Let's see, oops, wrong page. Still wrong page. Okay. So in order to use this linearization, we need to figure out what f prime of 0 is and what f of 0 is. Well, our function, we said, is e to the x. So what is f of 0? That is e to the 0, which is 1. And what is f prime of x? Well, this is a particularly straightforward one to take the derivative of. And then, so what is f prime of 0? It is also e to the 0, so it is also 1. So that means our linearization centered at 0, the tangent line that we're going to use is 1 times x, and I'll keep writing x minus 0 here, plus 1. Okay. Folks, the picture that I want you to see for this is that if I gave you the function e to the x, so here's the graph, say, of e to the x. That's not very exponential. It should be rising a little more steeply, but you get the idea. And if I said, hey, I want to evaluate this function right here at negative 0.015, how are we going to do that? This is our strategy. So what we do is we come up with the tangent line at a point that's easy to evaluate. That's our anchor point right there. That's the order pair 0, 0, right? So we built this the green line here, I should have done it in green, is the tangent line in red right here. Okay? And so rather than plugging negative 0.015 into the orange function, which is hard to do, we're going to plug negative 0.015 into the line and get a decimal approximation on it. And you can see that the y values of the point on the function and the point on the line, although my picture's a little bit makes them look a little bit far away, they're pretty close to one another. Those y values are close. So that's the idea of this procedure. Okay, so we get that L0 of negative 0.015 is equal to 1 times negative 0.015 minus 0 plus 1, which is negative 0.015 plus 1, which is about 0.98, well, which is, let me not say about, which is 0.985. Okay. So again, what we said is that this point, the y value on the red line here has a y value of about, or a y value of 0.985. And let's compare that to the actual value. So the actual value, that's tiny, I was hoping that to be bigger. The actual value is about 0.98511, and so you can see, again, we're accurate in this case to within 1,000th of the true answer.